Welcome to a very short video of demonstration of a tool Splitwalls, which creates split between the wall length based on the specified length that you have given, as well as assign accessories to it. Now in order to demonstrate, I will just quickly create wall. So let me just put as per our standards. Alright, so I'll go ahead and place some walls. I'll create a staircase well as well. And I've created lift shaft as well. Now in order to use this tool, one important thing to notice is that you cannot create a split between the poly beams. You have to split it manually at the corners. So either you can do this from here using split command, or you can, there is a tool which I have downloaded from warehouse. This is explode beam. So it is also kept in the library. You just double click on this beam and select a poly beam. So you select this and it will split it into pieces at the corners. That is very important. Now where the tool is kept, it is kept in common library Tekla macros and programming, and this is the tool Splitwalls. Double click on this and you will get this dialog box. Just click run on this. Now in order to ensure that this tool is connected with the current running instance of Tekla, you just click on split without selecting any wall element. If you receive this message, please select at least one wall part before clicking split, which means that it has already connected, but it is not able to see any selection in the model. Had it not been connected, it would give a message that model could not be connected. We will come to that part later. So I'll select all these wall panels and I will click on split. So it will run the macro. It will start splitting the walls, and at each wall split it will start placing the accessories. So you can see, meanwhile it is doing the split, you can see, I will explain you about here. This, you have accessories as wall to wall connection, top lifting insert and side lifting insert. So whichever tick is on is actually being placed in the model. In order to show that the model, if this command is executed, you will get this dialog box in the end. This dialog box is the statistics of the split, that the x direction total length of the wall was 332.8 meter, y direction was this, and the maximum weight of the element after the split was 5.7 tons. Okay, so I'll go ahead and redraw the view, and you can see easily that based on the type of the junction, it has placed the type of the while loop box connection successfully. We can quickly go ahead and see the statistics by performing the numbering. So I'll go and I will perform the numbering. Once the numbering is completed, I will go and extract our standard output. So here you will get the statistics of the wall after the splitting. So you will see that SW there are total 12 different types of walls with having 28 total quantity of the precast elements. The total lifting inserts including the side lifting is 150 and the while loop box required is 280. Since it is modeled everything as per the allomatic standard, so there is no problem in extracting this report. As well as if we go ahead and extract, let's say, drawing of one particular element using a master drawing catalog, we will get the desired mold drawing very fast. So I'll create a drawing in order to showcase. So let's just open the mold drawing for the same. I think this is the one which is created just now. So you will see that it has placed the lifting inside, lifting insert. The while loop boxes are placed as per the rules, starting with 200 at one end and 210 at the another end, and at the ends also. So they are never going to clash with each other when placed side by side, and even the mold drawing is also ready with the appropriate quantities mentioned in our descriptions and internal material list. I'll go ahead and close this. Now, while placing the lifting inserts also, you will see that the tool has intelligently placed the lifting inserts based on the weight of the element. For example, in this scenario, it has placed 4, while in some cases it has placed 3 because the weight of this is less, and all the lifting inserts are placed as per the center of mass location. In some scenario, you will see that 2 lifting inserts are only required. As of now, the rule that is working over here is that it is placed at specified spacing between the lifting is kept as L by 2, but these formulas can definitely be altered in the code in order to suit the requirement. So since all of this is done and is ready, I can quickly go ahead and let you know about the tool itself, what all things can be done from here. So whatever is the maximum length that you have allowed is to be kept over here, and whatever accessories you want, as I said, the tick has to remain there, and whatever you don't want, you can remove the tick from here. And this wall-to-wall connection, these are the attribute files, the name of the attribute. So for example, I'm working for a particular project KRP, and for that particular project the while loop boxes is to be replaced with some another different product. So how do we do that? We will load our ELE standard, and then we will save this as a KRP, and here we can make all the intermediate changes that we want to do. Suppose in the connectors we want to have a different while loop box, we can choose it from here and we will save it. Then you just need to copy this and paste it in your tool. So I will replace this by this one. So as long as it is able to find this attribute, it will execute this attribute whatever data is mentioned over here. So this way, at the beginning of the split itself, you can instruct the tool to place the while loop boxes lifting insert as per desired attribute and profile. Alright, if you later on want to change, so you can always change it using uh, by double clicking it, because everything is same, it is just that it has somebody has manually worked on it. So you can later on change anything that you want if you are not satisfied with it, or if later on you are adding some cutouts and you want it to readjust as per the center of mass, you can do so. It will automatically update as per your updation. Alright, so coming to a few more important points, what happens if the tool gives you the output that the model is not connected? In such scenario, you need to restart Tekla structures, and while you are restarting, you can close this window and you can restart Tekla structures and you restart Splitwalls, it will be connected. Then another question could be that how do I undo? The long process is you press Ctrl Z as many times it has manually worked on the system. The short process is you are not satisfied with it, then you simply open the same without saving it. So of course, if you're not happy, then you have to quickly undo. Then you can just open the Tekla file and open the saved version of the Tekla file. Alright, so that is one. And what happens if you want to have the split at a desired location? So in that scenario, before using the split command, you have to ensure that you perform the split as the desired location. Suppose you want to have purposefully the split at this particular junction, irrespective of where it is coming. So I'll just copy this into a similar one. In this one I will perform manually the split at my desired location is this. Now using the tool I will split all three of them. So in this scenario it will not disturb the location where you have performed the split, and it will create the connection required over there as well, while in this it will go as per the value that you have mentioned. So this is how the tool works. So far there has not been any glitches, but if there is any, it can be definitely taken care in the model itself. Alright, thank you for listening.